Hello students, welcome to the GATE Academy. My name is Murali Krishna. I am working as SME in the TGA. So, as the GATE exam is very soon, so we are very eagerly waiting for that exam, and we have lot of ambiguities how to prepare that exam and how to prepare all the subjects and how to memorize all the formulas. So, we need to solve lot of problems before that. So, it is very difficult to remember all the formulas at a time. So, how to recollect all the formulas? It is possible only with the help of solving a few questions which should cover entire all the topics which is asking in the frequently which are asking in the GATE. If you prepare such kind of questions, then definitely it would be really helpful for you for your GATE examination. So, in these power packed questions, we are going to discuss about a few questions in electrical machines which they are asked since from the last 8 to 10 years. What are the models they have covered? So based on that models, we are going to solve nearly 8 questions. So with the help of that questions, we can able to solve any kind of related questions in the GATE exam. Okay. So let us see all the questions one by one. So the given question as follows. A 250 volts DC shunt motor giving 14.92 kilowatt at 1000 rpm takes an armature current of 75 amperes. The armature resistance is 0.25 ohms and the load torque remains constant. If the flux is reduced by 20% of the nominal value before a speed changes, determine the final value of the armature current and speed. So, in the question, what they have given? They have given about the shunt motor is giving a 14.92 kilowatt power at a speed of 1000 rpm and it's carrying an armature current of 75 amperes. So, what they have done? If the flux is decreased by 20% of its normal value, then determine the final value of the armature current and the speed. So, how to solve this problem? Remember one thing, whenever if you want to solve any question irrespective of the subject, first of all read the question twice and understand the question belongs to which concept. Recollect that concept at that time. So therefore, how to solve this problem? This question belongs to speed control. This question belongs to speed control of DC motor. Speed control of DC motor using field flux control method. Using field flux control method question. So you need to recollect only one concept. What happens if the flux is suddenly decreased? What happens if the flux is suddenly decreased? What they have mentioned that condition? The torque remains constant even though if you reduce the flux by 20%. So what is the given data they have given? Terminal voltage is equal to 250 volts. Speed is equal to 1000 rpm. Armature resistance is equal to 0.25 ohms. And the power delivered to this load is 14.92 kilowatt. Flux is reduced. Flux is reduced by 20%. It means before changing the flux. How to solve this problem? Before changing the flux, identify parameters which are required for solution. After changing the flux, find out the same parameters. Then let us see what would be its final current and final speed. So first one is I am going to solve about final current. What is meant by the final current? Final current means after reducing the flux by 20%. They have given one condition is load torque remains constant. So load torque remains constant. Remains constant means as we know that torque is proportional to flux and armature current. Torque is proportional to flux and armature current. So what is the armature current they have given in the question? 75 amperes. So therefore torque is remains constant even though flux is reduced by 20%. Therefore torque before changing the flux is equal to torque after changing the flux. Therefore K into phi1 into Ia1 is equal to K into phi2 into Ia2, where K is the proportionality constant. Therefore what is your secondary current? It means after changing the flux by 20%, what is your final current? Ia2 is equal to phi1 Ia1 by phi2. So as they have mentioned that flux is reduced by 20%, it means phi into what is the Ia1 they have given? 75 amperes. So 75 amperes divided by what is this? Flux decreased by 20%. So remaining flux available inside the machine is 0.8. It means 80% of the flux. Therefore 75 by 0.8 will be 93.75 amperes. So what is the final current you got after reducing the flux? 93.75 amperes. It means if you reduce the flux by 20%, your armature current is increased by from 75 to 93.75 amperes. So what they have asked another question, it's a final speed also. It means after reduction of this flux by 20%, what is its final speed? Let us see how to find out this. So while solving this question means you need to find out the new speed. As we know that the relationship between back EMF as well as the flux as well as the speed. What is that? EB is equal to K into phi into omega. So I can write EB1 is equal to K into phi 1 into omega 1. It means before changing the flux, what is the back EMF? Similarly, EB2 is equal to K into phi 2 into omega 2. After changing the flux, what is the EB2? So therefore, I can find out speed from this. Let us see how to solve this question. So first of all, you need to find out EB1. What is meant by EB1? VT minus IA into RA. What is the VT they have given? 250 volts. So 250 minus what is the armature current before changing the flux? 75 amperes into 0.25 armature resistance they have given. So what is this voltage? This voltage is equal to 231.25 volts. So after changing the flux, what would be the induced EMF? EB2 is equal to VT minus IA2 into RA. This is your IA1 before changing the flux. So VT is 250 because we are not changing the supply terminals, but we have changed only by reducing the flux by 20%. Therefore 250 minus what is the IA2 we got? 93.75 into 0.25. So what is the voltage you got? 226.6 volts. Therefore, EB2 is equal to 226.6 volts. As we know that EB1 by EB2 is equal to phi 1 by phi 2 into omega 1 by omega 2. So therefore, in this what do you want? Speed N2. So omega 2 can be written as 2 pi N2 by 60. It is 2 pi N1 by 60. Therefore, can I write is N1 by N2? Therefore, N2 is equal to phi 1 by phi 2 is 1 by 0.8 because phi 2 is reduced by 20% into N1. What is the speed before changing the flux? 1000 RPM. What is the EB2 we got? 226.6 divided by what is the EB1 we got? 231.25 volts. Therefore, the resultant speed is 1225 RPM. So it means what? It means what is the conclusion we have made? If we decrease the flux by 20%, before change its speed, it means during transient condition, what will happen? During transient condition, what will happen? The armature current is increased suddenly. So during this constant torque, here remember one thing, what is the condition they have given? Here torque is a constant torque. So what you have observed in this conclusion? In this constant torque load method, your armature current IA1 is less than IA2. It means during this process, your armature is carrying greater than the load current. Therefore, your machine may get damaged. So to avoid this problem, we should not use this kind of mechanism for constant torque load. As of now, they have given the question for constant torque load application. But actually, this kind of application is not suitable for constant torque loads. You know, the flux control method is suitable for constant power load. Constant power load only. Constant power load. Okay. So, whenever if you find any field flux control method, you have to apply for constant power load to maintain the same rated current. But whereas in the given question they have mentioned that the field flux control method is utilized for constant torque load applications. Therefore, the armature current drawn by the machine is more than the rated value. Hence, your machine winding may get damaged. So therefore, from this conclusion, what we can say? Your DC shunt motor, that too field flux control method, should not be applicable for constant torque load applications. Okay. Let us see one more question which they are asking in the DC machines. Okay. So, how to find out the speed control method? How can you say that speed control method is suitable for constant power application? How can we say that constant field flux method is suitable for constant power applications? Because under steady state condition, your DC shunt motor field flux control method carrying the same amount of armature current. You have to remember that important point. Let us see the next question, what they are asking. The question as follows. A belt-driven 100 kilowatt shunt generator running at a speed of 300 RPM on 220 volts bus bars continues to run as a motor when the belt breaks. It means initially it is running as a generator. After that it is running as a motor because the belt was breaking. Then it is drawing a power of 10 kilowatt. It means once if it is acts as a generator, it will deliver a power of 100 kilowatt. But due to some malfunction, the belt was broken and it is acting as a motor. Now it is drawing a power of 10 kilowatt. What will be its speed? It means once if it is acts as a motor, what will be its speed? Given armature resistance is 0.025 ohms and field resistance is 60 ohms and contact drop, that is brush contact drop under each brush is 1 volt. Ignore armature reaction. So, how to solve this question? They have given that your DC, this is your armature system, this is your shunt field winding. So, and this machine is connected to a 220 volts DC grid. A 220 volts DC bus bar. This is plus and minus. So this is your RSH and this is your armature resistance and this is your back EMF. Armature resistance, back EMF. So initially it is acting as a generator because of some mechanical prime mover. Through a belt conveyor. So it is running as a generator. So it will give a current of armature current like this and it will send the current IL and it is shunt field current. Now what is the given question? Due to some malfunction, the belt was broken. Due to that malfunction, the belt was broken. So if the belt is broken means now mechanical input is suddenly removed. Suddenly if the mechanical input is removed, but due to inertia, its speed will not be changed immediately. Therefore, it doesn't have enough voltage to produce on its own. Then what it will do? It will take from the supply. So what it will do once if it takes from the supply? It will act as now motor. Once if suddenly the belt was broken, then it will act as motor. So now this is your grid. 220 volts supply. Armature resistance, back EMF. So now it is drawing load current from the DC grid. This is your armature current, this is your shunt field current. As you observe one thing, in both the cases, the shunt field is remains same. The shunt field is remains same, but only the difference is here it is giving armature current, here it is taking armature current. It is acting as a DC generator, it is acting as a DC motor due to mechanical prime mover failure. So therefore, during acting as a generator, how much power it is drawing? How much power it is generating? 100 kilowatt. Once if it acts as a motor, it is drawing a power of 10 kilowatt. So what they are asking is, suddenly if the belt is removed, it is acting as a motor, then at which speed it is rotating? They are asking that question. So first of all, take the data which they have given to us. So they have given terminal voltage DC bus bar grid is 220 volts and power output is 100 kilowatt and armature resistance is 0.025 ohms and shunt field resistance is 60 ohms and brush voltage drop is equal to total brush voltage drop, means 2 brushes you have, therefore 2 volts. Therefore the machine initially acting as a generator. Its speed is N1 they have given as 300 RPM. Now this specifications is only for generator. Now due to suddenly the belt is broken, then what is its parameters? Still terminal voltage is remain same. So VT is equal to 220, but power drawn during this case is how much? 10 kilowatt. And armature resistance is still remain same because nothing we have changed, only the mechanical primer was failure. So shunt field resistance is remain same, 60 ohms, and brush voltage drop is also remain same, 2 volts, and they are asking about this speed. How to find out this speed? So as we know that relation between E and flux and speed. What is this? E is proportional to phi into N. Therefore, E1 by E2 is equal to phi N1 by phi N2. Why I am considering phi in both the cases same? Because once if it is acts as a generator, its field is remain same. It is acts as a motor, its field is also remain same. Therefore, flux is constant. Therefore, what is your new speed? N2 is equal to N1 E2 by E1. So your objective is to find N2. So how to find out this N2? By using this data. In this, we have N1. How much? 300 RPM. But we don't know E1 and E2. Let us see how to find out that E1 and E2. If we want to find out E1 and E2, you should be very careful about that. Initially the machine acting as a generator. Later it is acting as a motor. Then how can you write that EB1 and EB2? According to that motor and generator equations. Let us see how to write that equation. So once, if it is acting as a generator, what is its armature current? IA is equal to IL plus ISH. We know that IA is equal to IL plus ISH. But what is IL is equal to? Power by terminal voltage. So when the machine acts as a generator, what is the power drawn by the machine? 100 kilowatt by terminal voltage is 220 volts. Therefore, its load current is how much? 454.51 amperes. How much current it is carrying? 454.51 amperes. What is your shunt field current? Shunt field current is VT by RSH. What is this VT? This terminal voltage is 220 volts and RSH, how much they have given? 60 ohms. So what is this current? 3.67 amperes. Therefore, from that equation, what is IA? IA is equal to 454.51 plus 3.61. What is the resultant current? 458 point some 18 amperes, right? 458.18 amperes. Now from this, what is EB1? EB1 is equal to VT minus, you can call it as I1, IA1 RA. What is VT? 220 minus IA is how much? 458.18. RA is 0.025. So what we got finally? The EB1 is equal to 233.45 volts. Now, due to that belt broken, due to the malfunction, it is acting as a motor. So it is acting as a motor means, what is your armature current? IA is equal to IL minus ISH. Remember one thing, in this both the cases, the load current is not remain same. Why? Because it is drawing a power of 10 kilowatt, but whereas your generator is delivering 100 kilowatt. Therefore, what is your IL? IL is equal to 10 kilowatt by, what is your VT? 220 volts. Therefore, what is your current? 45.45 amperes. But tell me, in both the cases, the shunt field remains constant or not? Shunt field remains constant. Therefore, ISH is equal to 3.67 amperes. But what is your IA? IA is equal to 45.45 minus 3.67. What is the resultant current? The resultant current is 41.78 amperes. So finally we got IA2. This is your motor current. Okay. Now what is your EB2? How to write EB2? EB2 is equal to 220 minus 41.78 into 0.025. What we got finally? EB2 is how much? 216.96 volts. So finally we have found that EB1 and EB2. So we got these two. Now it is very easy to find out your speed N2. What is your speed N2? N2 is equal to N1 into EB2 by EB1, right? Therefore, what is your N1? 300 into, what is the EB2 we got? 216.96 divided by, what is that? EB1? 233.45. Therefore, what is the final speed? N2 is equal to 278 RPM. What is the speed? 278 RPM. Therefore, suddenly if the belt is broken, initially your motor is rotating at a speed of 300 RPM. Initially your generator is rotating at a speed of 300 RPM. But due to some malfunction, your belt is suddenly broken. Belt broken means now it is acting as a motor, but it is drawing a power of only just 10 kilowatt. It is drawing a power of just only 10 kilowatt. But whereas in generator, it is giving 100 kilowatt. Therefore, how to find out that speed which is running by the motor? So therefore, N2 is equal to N1 into EB2 by EB1. So therefore, finally, your speed of the motor at this instant is 278 RPM. Okay. So these are the questions, means these are the models which we are expecting in the GATE every year. They are asking about like either voltage equation based questions or speed control method questions. Okay. In that mostly they are asking either flux control method or armature resistance control method. Okay. Next question is belongs to induction machines. So in induction machines, how they are asking, in which area they are mostly concentrating, let us see. In induction machine, how they are asking the questions? They are asking the questions based on equivalent circuit. Most important topic is equivalent circuit. If you focus mostly on equivalent circuit and speed control mechanism, then it will be very helpful for you for preparing the GATE exam. Okay. So, your next question is, a 4-pole 50 Hz 7.46 kilowatt motor has at rated voltage and frequency and starting torque of 160% and maximum torque of 200% of full load torque. Determine the full load speed. So what they have given the data? Poles is equal to 4. Frequency is equal to 50 Hz. And the power is equal to 7.46 kilowatt. And its starting torque is equal to 160% of full load torque. And its maximum torque is equal to 200% of full load torque. Therefore, can I write this as 1.6 times of TFL? This is 2 times of TFL. What is the question they are asking? What is the speed of the motor? What is the speed of the motor at full load? It means full load speed. So how to find out full load speed? So as we know that full load rotor speed is equal to synchronous speed into 1 minus slip corresponding to the full load. Is it correct? Am I correct? Therefore, rotor speed, full load speed is equal to synchronous speed into 1 minus slip times of the full load. Therefore, we should know what is the slip corresponding to the full load. We should know what is the slip corresponding to the full load speed. Let us see how to find out that. Before going to start this problem, we should know one thing. As we know the relationship between starting torque and maximum torque, from that we can find maximum slip. Therefore, TST by T maximum, T starting torque by T maximum is equal to, what is the relation we know? 2 times of slip corresponding to the maximum torque by 1 plus SMT square is equal to, what is the relationship between starting torque and maximum torque? 2 times of slip at maximum torque divided by 1 plus slip corresponding to the maximum torque. Therefore, what is that starting torque? 1.6 times of TFL by 2 times of TFL. In the given question, the data from that is like this. Therefore, SMT from this equation, what is the SMT from this equation? 0.04. What is SMT? From that, if you solve SMT, you will get 0.04. Now, your objective is to find out the speed corresponding to the full load. It means you require full load slip. How to find out full load slip? As we know the relationship between T full load by T maximum. T full load by T maximum. 2 into SFL into S maximum divided by SFL square plus SMT square. From this, as we know that TFL is full load torque, T maximum is equal to 2 times of the full load torque. 2 into, I don't know what is SFL, but I know what is slip corresponding to the maximum torque. 0.04 divided by SFL square plus 0.04 whole square. So from this, what is your SFL? SFL is equal to how much? It is 0.01. It is 0.01. Therefore, substitute this SFL in this. As we know that synchronous speed of a 4-pole machine is 120 F by P. What is that? 120 into 50 by 4. What is this NS value? 1500 RPM. So therefore, 1500 into 1 minus 0.01. What is its speed? 1 minus 0.01. What is its speed? 1485 RPM. So, what is the speed corresponding to the full load slip? What is the speed corresponding to the full load is 1485 RPM. How to solve this question? First of all, they have given the data belongs to starting torque and full load torque, maximum torque and full load torque. As we know the relationship between starting torque and maximum torque. Why we have to consider this relation? Because if you want to know full load speed, you require full load slip. How to get that full load slip? Whenever if you know the relationship between full load torque and the maximum torque, then we can directly find out the full load slip is equal to 0.01. If you substitute in this, you will get full load slip as 1485 RPM. This is one of the important model which they are asking frequently in the GATE. Next question is based on the equivalent circuit. Next question is based on equivalent circuit. How they are asking the question from the equivalent circuit in the GATE? How they are asking the question from the equivalent circuit? Let us see what is the importance of the equivalent circuit in the GATE exam and how they are asking the question and what are the models you are expecting. Okay. The question as follows. The rotor resistance and standstill reactance of a 3-phase induction motor are respectively 0.015 and 0.09 per phase. So what is they have given? For a 3-phase induction motor, the rotor resistance is 0.015 per phase and the reactance is 0.09 ohms per phase. 9 ohm per phase. At normal voltage, the full load slip is 3%. At normal voltage, the full load slip is 3%, or you can write 0.03 in terms of per unit if you want to write. Estimate the percentage reduction in the stator voltage to develop full load torque at half load speed. At half load speed. And they are asking is determine the percentage reduction in the stator voltage at full load torque and the speed is half load speed. It means it is running at a speed of half load speed but torque is full load. So let us see how to find out this question. So they have given that data is as full load slip is equal to 0.03. So what is the speed they have given at the end? What is the reference speed they have taken at the full load speed? What is the speed of the motor? They have given that speed is 100 RPM. It means at full load, what is the speed is? At full load, what is the speed of your induction motor? Is 100 RPM. So now how to find out this problem? So as we know that N1 is equal to Ns into 1 minus SFL, because it is a full load slip, it is a full load speed. So therefore 1000 into 1 minus what is the full load slip? 0.03. Therefore its speed is equal to 97 RPM. Its speed is 97 RPM. Now what the data they have given? The speed at half load speed. What is the half load speed? N1 by 2, that is equal to 97 by 2. What is the speed of this value? 40 48.5 rpm. What is its speed? 48.5 rpm. Now, what they are asking the question is percentage reduction in the stator voltage. How to find out that? As we know that torque is proportional to the E2 square, right? Torque is proportional to the voltage square. So, as we know that in the given data they have given constant torque load. It means at full load torque. Okay. T full load. At full load torque and same full load torque at half load speed. So, full load torque at half load speed. So, therefore, what is your full load torque? Proportional to the voltage square. As we know that torque is equal to Ks E2 square R2 by R2 square plus Sx2 whole square is equal to K into SE2 square R2 by R2 square plus Sx2 whole square. In this E2 square is before changing the speed. So I will represent it is with E2 dash square. And similarly, before changing the speed means its slip is S dash. So after changing the speed to half load speed, then it will be E2 square and I am considering it is S. Now K both are gets cancelled. Now R2 gets cancelled. I can write it as E2 dash square by E2 square is equal to R2 square plus S dash X2 whole square into slip divided by, what is this? R2 square plus Sx2 whole square into S dash. Therefore, E2 dash square by E2 square is equal to R2 square plus S dash X2 whole square into S divided by R2 square plus Sx2 whole square into S dash. But we know that what is this S dash? But we don't know what is this S. It means after changing the speed, that to half load speed. So what is the slip corresponding to this half load speed? S is equal to, what is the speed at this instant? What is the slip corresponding to it? 100 minus 48.5 by 100. What is the slip corresponding to its value? 51.5%, or you can write 0.15. Substitute this S in this. S dash is this R2 and X2. Substitute all the values in this. You will get 1.68. Therefore, E2 dash by E2 is how much? Therefore, E2 dash by E2 is equal to under root 1.68. Therefore, what is the percentage change in? Stator voltage? How to write that? Percentage change is equal to E2 dash minus E2 by E2 dash. Is it right? Or you can write inputs actual voltage before changing the speed by voltage after changing the speed divided by actual speed. So can I write this is nothing but E2 by E2 dash 1 minus 1 by, what is that value? Root 1.68. Then the resultant value is 22.84%. Therefore, the percentage change is equal to how much? 22.84%. How to solve this question? They have given that resistance, rotor resistance per phase, rotor reactance per phase, slip corresponding to the full load, and the speed they have given that 100 rpm. So, what is the speed corresponding at this slip? 97 rpm. Now, currently it is operating for a particular full load at this speed. Now, suddenly they have given the condition is at half load speed, but load torque is remains same. At half load speed, what is the slip corresponding to it? 51.5% or 0.515. Now, what they have given the condition? Before changing the speed, after changing the speed, full load torque is remains same. Therefore, I have considered in the same case, substituting that R2 and X2 and slip corresponding to that values, and finally you got E2 dash by E2 is equal to root over 1.68. Therefore, how to find out this? Percentage change is equal to E2 dash minus E2 by E2 dash. So, therefore, in induction motors, they are asking the questions from either equivalent circuits or from the starting torque and maximum torque relation based questions. Okay. So, now, after this, we are going to concentrate on next machine is transformers. So, in transformers, how they are asking the questions? In which area we have to focus more to answer in gate examination questions. So, let us see how to solve those questions in transformers. Basically, the transformer questions are mainly from either equivalent circuit or from the losses. Mainly they are focusing on equivalent circuit or from the losses. Equivalent circuit means in that lot of things you will get. Open circuit test and short circuit test. From that data, you have to find the given question. So let us see how to find out the transformer based questions and how they are asking the transformer questions. Let us see one by one. Take this question. A transformer with normal voltage impressed has a flux density of 1.4 Webers per meter square. So what is they have given? Flux density as 1.4 Webers per meter square. 1.4 Webers per meter square. And its eddy current loss is 1000 watts. And its eddy current loss is 1000 watts. And its hysteresis losses is 3000 watts. It means its hysteresis losses is 3000 watts. Therefore, what they are asking is find the total iron losses if voltage increased by 10%. Find iron losses if voltage increased by 10%. So, how to solve this question? So, first of all, we should know the relationship between iron losses as well as the voltage. What is the total iron losses we got? A into V power 1.6 F to the power of minus 0.6 plus B into V square. When this formula is valid, if V by F is not constant, in the question if clearly observe that the voltage is increased by the 10%, it means frequency is not changed. Therefore, V by F is not a constant. Therefore, we have to find what is the total iron losses present in this particular condition. So, how to find out that? As we know that voltage increased by 10% means V change is equal to increased by 10%. So, initially you have, let us assume V volts. Now it is increased by 10% means 0.1 volts. Therefore, it is 1.1 V. Therefore, this is the voltage change is equal to 1.1 volts. Now, your objective is to find out what is A and what is B. Let us see how to find out that A and B. From the data, what they have given is hysteresis loss is equal to 3000 watts. It means, as we know that hysteresis loss is equal to A into V power 1.6 F to the power of minus 0.6. Therefore, 3000 is equal to A into V power 1.6 and F to the power of minus 0.6. And moreover, after changing the voltage, what is your hysteresis loss? Is equal to some A into 1.1 times of 1.1 times of V whole to the power of 1.6 and F to the power of minus 0.6, because the voltage increased by the 10%. Therefore, your hysteresis loss is equal to A into 1.1 times of the volts whole to the power of 1.6 into F to the power of minus 6. If you take the ratio between these two, this one will get cancelled, AA will get cancelled. Therefore, from this, hysteresis loss is equal to 3495 watts. So finally, how much you got? 3495 watts. Similarly, what is the eddy current loss they have given? 1000 watts. Eddy current loss they have given as 1000 watts. But we know that what is the relationship between eddy current losses and the voltages? If V by F is not constant, it is V square. Therefore, eddy current loss after changing the voltage is B into 1.1 V whole square. If you take the ratio between these two, what we will get finally? Eddy current losses is equal to dB gets cancelled, V square gets cancelled, 1.1 whole square into 1000. It is 1210 watts. Therefore, what is they asking? What is the iron losses if voltage increased by 10%? Therefore, your iron losses is equal to 3495 by 1210. What is the resultant? 0 plus 5 is 5. 1 plus 9 is 10. 0, 1. 2 plus 4 is 6 plus 1. 7. 3 plus 1 is 4. So, totally 4705 watts. Total is how much? 4705 watts. 0 plus 5, 5. 1 plus 9 is 10. 0, 1 is there. 2 plus 4, 1. Plus 6, total 7. 3 plus 1, 4. Therefore, the total iron losses which is obtained by increasing only just 10% of the voltage. It means if you increase the voltage by just 10%, the losses are increased by, it is total loss 4000, but it is increased to 4705 watts. It means the increase in losses are 705 watts. Therefore, increasing of only the voltage, what happens? The iron losses are increases. Therefore, this model question is very important in the gate point of view, because they will asking very frequently on basis of equivalent circuit as well as the losses. And this question is belongs to the transformer losses. Understand? So, let us find one more question which is related to that equivalent circuit, that is open circuit test. So, how we are going to find out that parameter, and you can go. Now, let us see the next question in the transformers, how they are asking the question. The question is like this. A single phase transformer, it means they are asking from the single phase. Mostly you will experience questions from on single phase. Rarely you will get on three phase. Means either they will use three single phase transformer bank connection, like either star connection or delta connection, three phase transformers. But they are focusing more on single phase transformers. How they are asking the question is, a single phase transformer with a ratio of 440 volts by 110 takes a no load current of 5 amperes at 0.2 power factor lagging. If the secondary supplies a current of 120 amperes at a power factor of 0.8 lagging, estimate the current taken by the primary winding. So, how to solve this problem? So, first of all, understand the given data. What they have given the data? Voltage ratio. Voltage ratio, how much they have given? 440 by 110 volts. Voltage ratio is equal to 440 by 110 volts. Therefore, what is the no load current drawn by the machine? 5 amperes, and its corresponding power factor 0.2 lagging. 0.2 lagging means what is your phi naught? Cos inverse of 0.2. What is that angle? Cos inverse of 0.2 is nothing but 78.30 degrees. Now what they are asking, the load supplied, the current is about, secondary side supplies the load current is how much? 120 amperes at a power factor of 0.8 lag, at a power factor of 0.8 lag. Therefore phi 2 is equal to cos inverse of 0.8. How much is value? 36.86 degrees. Now what they are asking is current drawn by the transformer from the primary side. So how to solve this question? By using the phasor notation. This is your voltage, this is your current. So this is your no load current I0, and that too it is a lagging current, secondary side I2. The angle between these two is, they have given 78.30 degrees. Now they are asking the primary side current, means you have to transfer the secondary side current referred to primary. So we know that I2 dash, secondary side current I2 dash is equal to K times of I2 dash referred to primary is K times of I2. Therefore what is your K? 110 by 440 into 120. Therefore this value is equal to 30 amperes. So we got this is 30 amperes. Now the resultant is nothing but your primary side current drawn by the transformer. This is your I1. But what is the angle made by this I2? This angle made by this I2 is 36.86 degrees. Now what is the angle between these two? Now tell me, what is the angle between these two? It is 78.30 minus 36.86. Therefore this angle, power factor angle phi is equal to 78.30 minus 36.86. Therefore the resultant angle is 41.36 degrees. What is that? Resultant angle is 41.36 degrees. Then how to find out that I1? That is a parallelogram. It looks like a parallelogram or not? Therefore I1 is equal to root of I1 square plus root of I0 square plus I2 dash square plus 2 I0 I2 dash cosine angle between I2 dash and I0. What is that cosine angle between I2 dash and I0? We got phi 2 is equal to, we got phi is equal to 41.36 degrees. 41.36 degrees. What is your I0? 5 amperes. What is your I2 dash? 30 amperes. So therefore, if you substitute these values, the resultant value you got 34.45 amperes. Okay. Generally, how we will commit a mistake in this kind of questions? They are asking about referred to primary. What we will do? Generally, we will find out that referred to primary means we need to transfer secondary side current to primary side. We will stop at 30 amperes. The resultant answer you are expecting about root of 30 square plus 5 square. Generally, what we will do, right? Some options you will get 30 plus 5, 35. One option will be 35 will be there. Second option is root of 30 square plus 5 square. That is also one possibility. But we should not forget this kind of basic thing. What is that? You have to consider the resultant angle between, the resultant power factor angle between I2 dash and I0. Therefore, how to solve this current? I1 is equal to under root I0 square plus I2 dash square plus 2 I0 I2 dash and the cosine angle between power factor. So that is that amperes. Therefore, finally, this is your current. This is a very, very important model question where we generally commit a mistake. So while solving these questions, we should not commit any mistake on this kind of problems. So how they are asking in transformer problems? They are asking one thing is on losses, another one is on this kind of primary side based questions like in equivalent circuit based questions. Now let us see our last machine, that is synchronous machine. So in the synchronous machine, how they are asking the question? They are asking the questions only in two models. First one is regulation based question, and the second one is EMF equation based question. It means we have only two model questions. One is regulation based questions, another one is EMF based questions. Based on these two only, they are asking very frequently in the gate. Let us see one by one what is that question and how they are asking. Take down this question. A 4-pole 3-phase 50 Hz star connected alternator has a 60 slots. What they said? Number of poles is equal to 4 and the frequency is equal to 50 Hz and the number of slots are 60. Number of slots are 60 with 4 conductors per slot. With 4 conductors per slot. So therefore 4 conductors per slot, the total number of slots are 60. Therefore total number of conductors are 60 into 4, that is equal to 240 conductors. Coils are short pitched by 3 slots. Coils are short pitched by 3 slots. Remember, this is very important point. Coils are short pitched by 3 slots. If the phase spread is 60 degrees, phase spread m gamma, we will denote it with m gamma. Phase spread is m gamma. How much they have given? 60 degrees. Find the line voltage for a flux per pole. For a flux per pole is 0.943 Webers with distributed sinusoidally. All the turns per phase are in series. It means what they have given? They have given number of poles, they have given frequency and the slots, and number of conductors per slot is 4. Therefore total number of conductors are 60 into 4, 240. And the coils are short pitched by 3 slots. And the phase spread they have given 60 degrees. And the flux is 0.943 Webers. What they are asking? Line voltage. What is that line voltage? √3 times of phase voltage. That's right. Why? Because it is a star connected alternator. So what is your EPH? Induced EMF per phase. What is that? 4.445 F turns per phase. 4.445 F turns per phase, Kp and Kd, where Kp and Kd are called pitch factors as well as distribution factors. In this we know everything. We know flux, we know how much? 0.943. Frequency we know 50 Hz. But we have to find out turns per phase, Kp and Kd. Turns per phase is equal to, tell me first of all, how many turns we have? One turn contains 2 conductors. Therefore, totally how many conductors we have? 240. Therefore, how many turns? 240 by 2, that is equal to 120 conductors. Therefore, 120 conductors. Therefore, number of turns per phase is equal to 120 by 3 and it is equal to 40 turns per phase. Therefore, we got turns per phase as 40. Now, we have to find out Kp and Kd. What is the Kp? As we know that Kp is nothing but cos alpha by 2. Kp is nothing but cos alpha by 2. But what is the alpha? What is the alpha? We should know. We have to know that. What is the alpha? Alpha is equal to how many? Short pitch by how many slots? 3 slots. So 3 into slot angle. 3 into slot angle. What is that? 3 into. How to find out that slot angle? Number of. Again record. How to find out the slot angle? Alpha is equal to 3 into slot angle is nothing but pole pitch by slots per pole. How many slots are there? 60. How many poles we have? 4. Therefore, it will be 36 degrees, right? Because 4 15s, 15 12s, 12 these are 36 degrees. Therefore, cos of alpha by 2 is equal to cos 18 degrees is equal to how much? 0.95. So this is nothing but your Kp. Next, what we are going to find out next? Kd. How to find out that Kd? Kd is equal to sin m gamma by 2 by m sin gamma by 2. What is that? Sin m gamma by 2 by m sin gamma by 2. But as we know that, what is the m gamma they have given? What is m gamma they have given? Phase spread. M gamma is equal to 60 degrees. But we don't know what is m, what is gamma. Let us find what is m, what is m gamma. M is equal to, as we know that in alternators, what is the m value? Number of slots per pole per phase. Therefore, 60 slots, how many poles we have? 4 poles. How many phases we have? 3 phases. Therefore, m is equal to 5. Then what is the gamma? Simply 60 degrees by 5. How much is value? 12 degrees. Therefore, what is your Kd? Sin m gamma by 2 by m sin gamma by 2. Its value is equal to 0.9. Its value is equal to 0.975. Therefore, finally we got Kd and we got Kp and we got turns also. Then what is your answer? Finally, your answer is equal to 4.44 into 0.943 into 50 into 40 into Kp. How much we got? 0.95 into what is the Kd we got? 0.975. Therefore, what is the resultant answer? 7630 volts. What is that? E per phase is 7613 volts. E per phase. Then what is your E line voltage? L is equal to root 3 times of E phase. 7613 volts. Then the resultant is 13185 volts. Okay, 13185 volts. Clear? Now let us see the next question, how they are asking. The next question is belongs to the regulation based. It means that how to find out that parameter which they have given in terms of the angles like load angle, power factor angle. How they are asking the question, let us see. They are asking the questions like this. A 3-phase 10 kVA 400 volts 50 Hz star connected alternator supplies the related load at a power factor of 0.8 lag. At a power factor of 0.8 lag. If armature resistance is 0.5 ohms and synchronous reactance is 10 ohms. What they have given? Armature resistance is 0.5 ohm and synchronous reactance is 10 ohm. Now what they are asking is find the power angle. Find the power angle. So how to find out that power angle? So what they have given that voltage? What is the voltage they have given? V is equal to 400 volts. What they have given? V is equal to 400 volts. And its power is equal to, rated kVA is equal to 10 kVA. And that is a star connected alternator. So how to find out this power angle? How to find out this power angle? This power angle can be found by drawing its phasor diagram. What is the phasor diagram for this particular? What is the phasor diagram for this particular alternator? As we know that this is your E and this is your V and this is your power factor load current. What is the power factor they have given? They have given the power factor as 0.8, and therefore phi naught is equal to cos inverse of 0.8, and it is 36.86 degrees. Now, what is the angle between generated induced EMF as well as the load voltage? Is load angle or power angle, as we know that load angle or power angle. And what is the angle between voltage and the load current? Is power factor angle, right? So as we know that, what is the equation, what is the voltage equation for the alternator? E is equal to IA RA plus IA XA plus load voltage VL, or you can write VT. You can write VT. So if the load current is lag with some angle of phi, so how to write out that? IA RA exactly line parallel to this current. IA XS is perpendicular to this. IA XS is perpendicular to this current. Therefore, if we extend this line like this, could you please tell me what is this? This is IA XS. So now we have to find out what is the length of this. This length is nothing but VT cos phi, and this length is IA RA. Therefore, this total length is VT cos phi plus IA RA. Similarly, what is this length? VT sin phi, because it is opposite side. This is your resultant length. Therefore, how to find out that angle, this load angle? Let us see. I am considering tan of phi plus delta. It means I am considering these two. Therefore, this is my adjacent side, this is my opposite side. What is the tan delta plus phi? VT sin phi plus IA XS divided by VT cos phi plus IA RA. What is that VT they have given? 400. What is that sin phi? If it is 36.86 for the power factor, then what is your sin phi naught? Sin phi naught is equal to 0.6. Correct? So for sin phi naught is 0.6 plus what is the IA they have given in the question? They have given the armature current. They have not mentioned the armature current anything. So how to find out that armature current? IA is equal to power by star connected root 3 into VL. So what is this current? 14.4 amperes. What is this current? 14.4 amperes. Why I have considered root 3 VL? Because it is a star connected alternator. Therefore, what is your IA? 14.45 into armature resistance is 0.5. And therefore, what is your VT? 400 into what is your armature reactance? 0.8 plus the current offered by the machine is 14.45 and the reactance is 10. Then what is that phi plus delta? What is that phi plus delta? Tan inverse of the total value is how much? The total value which we got is 1.44. What is the total value we will get? 1.44. Then phi plus delta is equal to how much angle we got? 55.26 degrees. Therefore, from this what is the delta? 55.26 degrees minus phi. How much? 36.86 degrees. Therefore, the power angle or the load angle is 18.39 degrees. So, how to find out that delta? Delta is nothing but load angle or power angle. How to find out that load angle or power angle? Just we have to read the data what they have given. So, from this, how to find out that load angle? We need a phasor because it is very difficult to find out that load angle. Once if you know the phasor, then only you can able to solve that load angle. So how to find out this? So as we know that E is equal to IA RA plus IA XA plus VT. So VT, I is the lagging current. At which power factor it is lagging? It is lagging a power factor of 0.8 and its angle is 36.86 degrees. From this, I've just found out the tan between these two. I got this tan, and if I got phi plus delta is equal to tan inverse of, if you solve this, you will get 1.44. From this, phi plus delta is equal to 55.26 degrees. Therefore, delta is equal to 55.26 degrees minus 36.86. Therefore, delta is equal to 18.39 degrees. Therefore, the power angle or load torque angle is 18.39 degrees. Okay. Thanks for watching this. Thank you.